Good day to all. I am Dr. B. Yamini. This is the continuation video, that is part 2 video for the visible surface identification. In part 1 video, we have seen about the visible surface identification and its types called as object space method and image space method. Under image space method, we have seen about back face deduction method, depth buffer method, A buffer method, and in today's session we are going to see the remaining methods called as Scanline method, and then BSP, that is binary space partitioning tree method, and then area subdivision method, and last is Octree method. So these are the methods that we are going to see in part 2 video. So the remaining methods, the Scanline method. In this method, it removes the hidden surfaces, which is an extension of Scanline algorithm for filling polygon interiors. It will identify the lines alone, which removes the extra spaces, extra surfaces will be removed, and it removes the hidden surfaces also. So which will identify the visible surface by using the Scanline method. It has two tables, edge table and the polygon table. Edge table has coordinate end points for each line in the scene. So if I am going to consider this line, the two end points will be stored in an edge table. Polygon table contains coefficients of the plane equations. The surface plane or the view plane equations coefficients will be stored in polygon table. So the next method is binary space partitioning tree method, in which surface painting is done on the screen. That is, by using a painter's algorithm, we will be painting the surface of the view plane. So it is painted like front and back. In front you will be using one color, and in the back side we will be using another color. Let me consider a plane which has two portions, front and back. Front will be used painted by some other color, and back will also be painted by some other color. Similarly, that back part is going to be another plane which is going to have its own front and back, which will be painted with another colors, that is different colors, by using painter algorithm. And this type of identification of visible parts is called as BSP, that is binary space partitioning. Binary in sense two, that is it has two parts, that is front or back. Space partitioning, that is the surface is painted by using painting algorithm, and it is partitioned, it is separated. That is why it is called as binary space partitioning method. And next method is area subdivision method, that is successively dividing the total viewing area, that is the total viewing plane is being successively divided into smaller units, and that smaller rectangles, until each small area is the projection of the part of a single visible surface or no surface at all. So until you get a very small area of a rectangle, you have to divide it further and further like fractals, or else you should stop when you don't have any other surface to divide further. So this is what called as area subdivision method. And the next method is Octree method. In this Octree method, used for the viewing volume, hidden surface elimination is accomplished by projecting Octree nodes on the viewing surfaces. So it has Octree nodes in the viewing surfaces, which has front and back nodes. The front nodes are identified, so totally 8 numbers will be there, that's why it is called as Octree. Front nodes will be identified with 0, 1, 2 and 3, and back nodes will be identified with the number 4, 5, 6 and 7. So totally 8 nodes are there, that is Oct nodes, which forms as a tree, like as we seen before in binary space partitioning. It has its front and back part, which gets painted using painting algorithm again, but here it uses only 8 nodes. The application of this visible surface identification is real-time 3D magic. It is used in real-time 3D magic, implementation of 3D transformations, and correct view about 3D, three-dimensional objects will be obtained. Thank you.